You're listening to Mentoring Developers. Let's quickly define TDD and solid. So TDD is, I'll tell you the acronym, you define it in a short sentence. Test-driven development, and solid is another term that's, let's not define that. Let's just talk about the concept of TDD and solid very quickly.
Yeah, well, we'll start with solid. Well, I mean, for me, they really tie together. I guess let's start with TDD. So TDD is test-driven development. That's what it stands for, literally. I actually refer to it as test-driven design because it really truly impacts the design of your application and the way that you think about your application more so than the actual fact that you're testing it, right? So to me, testing, even though that's the first word, is actually just kind of a nice side effect, right? So test-driven development, I call it test-driven design. Most people, when they talk about test-driven development, they're really kind of referring to test-first development, which means that you write unit tests for your code first, literally before you've even written a line of code. You make sure that test fails. And the true TDD purist fashion would be that test fails because you haven't written the code yet, right? It fails compilation. That's your first test. And then you go and you write only the bare minimum amount of code that it takes to make that test pass. And in doing so, you are thinking about how to structure your system so that code is easily testable. And this drives a loosely coupled component-based modular system so that you can isolate the concern of each of those components because these tests that you're writing are pretty specific. They're pretty specific to that behavior of that component, right? So, I mean, I give the calculator example. It's kind of trite, it's kind of stupid, but in the calculator, you have a method called add, and it takes in two numbers, and the test for that is, verify that, assert that when I pass in 2 and 1, it comes, but the answer is 3, right? And then maybe I'll write a couple other tests when I pass in int.max value and int.max value, what happens, right? Do I get an exception? All those kind of edge cases and everything. And, right there, it is encouraging you to think about, well, what are some of the other things that I can pass in, right? What are some of the other ways that this component can be used or abused? And do I have to actually deal with those cases, right? How do you deal with an addition method that adds in max value and max value? It's just not going to happen, so don't deal with it. Or if it could happen, you now need to design it separately. But as you start really truly doing TDD, you find ways to design your components so that it's very easy to test them, and that's when you kind of get into solid, right? So solid it's a list of acronyms: single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, dependency injection. We're not going to talk about all those. I've heard podcasts that are an hour and a half just on
5
those.
out of 5.
Yeah.
It's impressive.
Oh, I don't say it just to brag. I say it because I really do think these are the true kind of meaning of object-oriented design for me, right? There have been whole books on object-oriented design that talk about encapsulation, polymorphism, all of this stuff. But for me, those things are really important. And honestly, the two of them, the first one and the last one, are the most important. They're all important, but the first one and the last one are the most important. Single responsibility. So you don't have these God components that are just doing everything in the world, right? And they end up being 5,000 lines long, and your entire giant application ends up being 3 classes, right? You have not broken the problem down into smaller parts, which, as I described in my story, right, had I known that, I would have broken that problem down into single responsibilities rather than having these giant classes. I was treating that big, huge pipeline as a single responsibility, and it was all one big thing, when really it wasn't. It was a pipeline of first this happens, then this happens, then this happens, this happens, and I was on the last step of 20 steps. And if I had just been focusing with a laser focus on that last step and the single responsibility of that last step, it would have been far, far easier. And in fact, I wouldn't even need to kick up BizTalk. I would be just implementing the behavior of that component. And I would do that with dependency injection. So dependency injection or dependency inversion is, in a nutshell, I mean, there's a big, long computer science-y term for it, but in a nutshell, it basically means you just declare the dependencies that you need in order to run, and other people are responsible for creating those dependencies and giving them to you. And then you just consume them. You don't know where they came from. And if you're using interfaces and things like that, you literally don't even know what the implementation is. You define a contract with the interface and say, give me something that meets this contract, and I'm going to use it. I don't care how it works. I don't care what it does. I'm going to use it, and I'm going to do something, right? And so using this approach kind of forces you to break the problem down into smaller parts, right? And you say, the single responsibility of this component is to calculate the price of my cart, right? Just add a bunch of things together, right? And then I will depend upon another component which is responsible for calculating the taxes on that, right? So even though you might at first think about calculating the total prices of all the things in your shopping cart as a single responsibility, including tax calculation, well, that tax calculation is actually kind of a difficult problem. And it might change. It might be a web service call at some point to get the live tax information, something like that, right? And so that part, that the calculation of taxes, might be big enough to be its own single responsibility. So separate it out and then pull it back in as a dependency that just says, you make a call that just says, hey, calculate the taxes on these things, right? I don't know how you're doing it. Just calculate it and give it back to me.
Yeah. And once you have done that, then if there is a problem in the tax calculation, you know exactly where to go and look at the code, and you can add more tests. And obviously you can develop that feature using tests, using TDD. But even after the fact, if you find a problem, you can isolate that problem to that component instead of having to look at everything.
Exactly. So in the way that you just said that, you were describing the benefits of both dependency inversion and unit testing all in once, right? So when you're doing unit testing, you're focusing your test just on that shopping cart. You're not worried about tax calculation. And then you write other tests to test just the tax calculation module. And so when you break that tax calculation module, as you inevitably will, those tax calculation tests will fail, and you're much more quickly able to narrow down where the problem is in your system. Rather than in my BizTalk example, when I had 20 steps together, the whole thing blew up. I had no idea which of the 20 steps was blowing up, right?
Yep. Thank you so much for listening.
For show notes and transcripts, visit us at mentoringdevelopers.com.